Okay, so how many participants are there now? 7. That means 6 have joined, including me, 7. Am I audible? Hello? Please respond. Am I audible? Okay. So this is a trial class, okay? Because the Zoom recording is recorded in the web browser, web cloud. And because of that, I want to check how the quality of the recording will come out. Depending on that, I will decide whether to continue with the Zoom or to follow another format, okay? So today, let others also join. Only 7 have joined. Okay? Just wait for 5 more minutes. So I have here IAC past paper questions. You can switch on your audio so that you can ask, questions if you have, instead of remaining silent. Yeah. In one of my phone, I'll also join to see how things are going on. Let me go to Zoom. Oh, 10 app. Join. Okay, sir. Zoom. Okay. Join a meeting. Meeting ID is 594-594-153-4538. Join. Then meeting passcode is capital G Y 0 PK 1. Okay. So let's see how this is.
Recording in progress.
Just monitor this. Take out the result. So by now there are 13 participants. I'll just begin because it's just a trial. I don't think everyone will be able to join. Maybe they are not aware also. So if I'm audible, if there's any problem with this thing, you can tell me, okay, if I'm not audible or if something goes wrong. Okay, so let's start with the questions. So I have here past paper, IAC 2009. I think this is visible. So which of the following solution will have a lower vapor pressure and why? Okay, so there are two solutions. The first one is a 5% solution of cane sugar. Cane sugar is sucrose, chini, you must be knowing. Its formula is given here, C12H22O11. And there's another 5% solution of urea. So both are 5% solution. Okay. So which one will have a lower vapor pressure? First of all, you must be knowing cane sugar, that is sucrose, and urea, both form ideal solutions. Okay. And both are 5% solutions. So what decides how much of vapor pressure will go down? It is decided by the number of moles of solute, isn't it? You've got to find which one has higher number of moles. Okay, whichever has higher number of moles, it will have lower vapor pressure, because more number of mole means vapor pressure will be lowered more. Okay, so let me just start solving this in GoodNotes. So I have here GoodNotes. So let's start solving. So what you have got here is a 5% solution of C12H22O11. So the percentage doesn't matter. What matters is how many moles are there. So I think you understand what's the meaning of 5% solution. It means there is 5 grams of this compound C12H22O11 in 100 milliliter of solution. Okay. So now let's find out 5 grams of this compound, this one. Okay. 5 grams of this compound has how many moles? Okay. So how do we calculate the number of moles? You know that number of moles can be calculated by simply dividing mass in grams, isn't it? By dividing with molecular mass. We have mass 5 grams over here, this one, but we don't have the molecular mass of this. So first we calculate its molecular mass. Okay. So molecular mass you can find from the formula. Understood? So molecular mass will be how much? Molecular mass will be, carbon's mass is 12. And how many are there? 12 only. Hydrogen's mass is 1. How many are there? 22. And oxygen's mass is 16. How many are there? 11. So how much it will be? This one is 144. This one is 22. And this one is 176. Yeah, is that right? Yeah. So what will be the total molecular mass? 6 and 4 is 10, and this one's 12. 8, 9, 10, and 4 is 14. Lastly, 1 more 3. So 342. That's the molecular mass. Okay. So that's the molecular mass. So if you divide and find out the number of moles. So number of moles of sucrose, that is sugar, is how much? Mass is how much? 5 divided by molecular mass is how much? 342. Okay. In fact, in this case, you need not even divide. So let it be. We'll compare it later. Now we have what? We have a 5% solution of 5% solution of urea, which means there is 5 grams of urea. Okay.
Yeah,
In 100 ml of solution. That's the meaning of 5%. Okay. So if you have 5 grams, how many moles there are? So what do you do? Find out the number of moles of urea. Okay. How do you find the number of moles? Mass in grams divided by molecular mass. What is the mass? Mass is 5. What is the molecular mass of urea? From the formula of urea, which is NH2CO NH2, if you calculate by adding the masses of all the atom, it will come out to be 60. You can try. Now just check which one has more number of moles. Which one is larger? 5 by 342 is larger, or 5 by 60 is larger? Naturally 5 by 60, because over here the denominator is less. Over here denominator is 342. So when 5 is divided by 342, this number is going to be small. Whereas this number 5 is divided by 60, the number is larger. So that means urea has larger number of moles. And when urea has larger number of moles, colligative property depends on number of moles. That means urea will have more depression in, more lowering of vapor pressure. So which one will show lower vapor pressure? Naturally, the one which has higher number of moles. That means urea will have lower vapor pressure. So I think you understood how we calculate. In fact, in this case, the calculation was also not needed. You know why? Why? It's because you can look at the formula of sucrose. You know, it's such a big formula. So its molecular mass is going to be large compared to the molecular mass of urea. Molecular mass of urea is much less. So that means when both are 5 grams, 5 grams. So when you divide 5 by a large molecular mass, in case of sucrose, the number of moles are going to come out less. And with less number of moles, it won't be able to achieve much lowering of vapor pressure. So that way, in that sense, without even dividing or calculating, one could say that it is the urea which shows lower vapor pressure. Okay. So that was IAC. That was IAC 2009. Okay. Yes. Then we have this IAC specimen paper 2024. Okay. So what does it say? Water vapor and liquid water are in equilibrium in a container. So there's water vapor and liquid water at room temperature. The vapor pressure of water is 25 mm of mercury. Okay, so vapor pressure of pure water is given. The volume of water is V milliliter. So how much water we've got? V milliliter of water. What will be the vapor pressure of water if the volume of water is reduced to V by 4 without any change in temperature? Okay, so it is saying there's V milliliter of water, and at room temperature, its vapor pressure is 25 mm. And now, without doing anything, they are not adding any solute, they are not converting water into any solution, they are simply changing the volume of pure water. So they are reducing the volume to 1/4 of V. So the final volume is V by 4. So what will happen to the vapor pressure? You see, vapor pressure of any liquid, it depends on many factors. What are those factors? Okay, let me just go here. Vapor pressure of a liquid. Okay, let me do this. Vapor pressure of a liquid depends on what? Temperature. Vapor pressure of a liquid depends on what else? It depends on. It depends on the nature of the liquid, isn't it? Whether liquid is volatile or not. Vapor pressure of a liquid also depends on
Impurity.
impurities, right? But it doesn't depend on the volume of liquid, isn't it? Whether you take little bit of liquid or large amount of liquid, vapor pressure will not depend on that. You know why? Because vapor pressure is the force calculated on a unit area. So whether you take less liquid or more liquid, the area we calculate is always going to be one area. So that means vapor pressure of a liquid is independent of amount of liquid. You know, how much liquid you take, that will not decide the vapor pressure. Vapor pressure is decided by only temperature, nature, and impurity. That means even when the volume of the liquid you reduce to V by 4, it will have the same vapor pressure. Vapor pressure won't change. Okay. Now what? Now next question. Next question in Kindle. Vapor pressure won't change. Then next, will there be a change in vapor pressure over here? Will there be a change in vapor pressure if more water is added to the container? No. Whether you take less water or more water, the amount of water will never affect vapor pressure. It will not change because vapor pressure does not depend on amount of liquids. Okay. So that was IAC specimen paper 2024. Then what do we have? Then we have some more questions here. These are not so important. They are not so important, so we'll not solve them. This one, let's see. What will be the vapor pressure of a solution containing 5 moles of sucrose, that is sugar, in 1 kg of water, if the vapor pressure of pure water is given? Vapor pressure of pure water is 4.57 mm. Okay, so let me solve this also. Okay, split. Good notes. Okay. So what do you have here? See, there is what will be the vapor pressure of a solution. Remember, whenever we calculate vapor pressure of a solution, we've got a law. That's Rawls' law on vapor pressure of a solution. First of all, you should know that this solution is an ideal solution. Why? Because sucrose will never form non-ideal solution. Okay. So what was the formula for vapor pressure of a solution? Vapor pressure of a solution is given by the product of mole fraction of the solvent. Remember, because even in a solution, it is the solvent which is forming the vapor. So you've got to take the mole fraction of the solvent, which you write as X1, into the vapor pressure of pure solvent. Okay. Now, vapor pressure of the solution you can find using this formula, but if you have mole fraction of solvent is not given. Okay, do we have mole fraction of solvent? No. What else is given? 5 moles of sucrose is there in 1 kg of water. Only that much is given, isn't it? So what do we do? Let's find the number of moles of water. Okay, 1 kg water means 1000 grams. Is that right? Why we need to get the mass of solvent in grams? Because what is the formula for finding number of moles? Number of moles is what? Mass in grams, not mass in kilograms. So mass in grams by molecular mass. What is the molecular mass of water? It is 18, you know. So that's why I converted that 1 kg into grams. So you got 1000. Okay, 1000 divided by 1 kg is 1000 grams, isn't it? 18. How much this will come out to be if you divide? Let me try dividing it. 55 point something I'll get. Calculator, where is it? So I have to divide 1000 by how much? Molecular mass of water, that is 18. Oh, how much is that? It is 55.56, isn't it? So it is 55.56. Where is it? Good notes. So 55.56. Okay, 55.56. Now, number of moles of solvent we have, that is N1 is 55.16. What is the number of moles of solute given? 5 moles of sucrose. So number of moles of solute, which we write as N2, is how much? 5 moles. Okay. So what is the mole fraction of the solvent then? X1. Mole fraction of the solvent will be number of moles of the solvent, that is water, which is 55.56, divided by the total number of moles. So total number of moles will be 55.56 plus 5 moles of solute, sucrose, isn't it? So how much that will be? Again, let's calculate using calculator. Where is my calculator? Here. So what you do is 55.56 you divide by 55.56 plus, you got to add the number of moles of solute also, which is 5 moles. How much you are getting? 0.917. Okay, so let's find out then. So 0.917, 0. How much it was? Oh, calculator, I forgot. Okay, 0.917. Yeah. So good notes. Come on. So 0.917. That's the mole fraction of solvent. Now we can easily get the vapor pressure of solution. Vapor pressure of solution is given by the product of mole fraction of solvent and the vapor pressure of pure solvent. Mole fraction is 0.917 into what is the vapor pressure of the pure water given here? You see over here, 4.57. So it will be 4.57. So let's multiply that with 4.57 in calculator. Calculator this into 4.57. No. That is not 4.57. Yes. So 4.19. That is the vapor pressure of the solution. Good notes. Okay, so it is going to be 4.19 mm. So this is how we solve this. Okay, see, today it is only trial I'm doing. Okay, I want to see how this video gets recorded, so that if the quality is good enough, I will put it in the YouTube. If this doesn't work, then I've got to separately record and put it in the YouTube without involving you all. Okay, so presently I'm just halting this because it's just a trial, and I'll see how the video is going to come out in that website, and then I will let you know. Okay, so thank you for your time. Where is my Zoom? Here. So I'm ending the meeting. Okay, end the meeting.